Hello viewers, in today's class we are going to discuss yet another important problem from integrals, right? And in this class we'll discuss this integral using the concept of beta function, right? So the beta function is also known as Eulerian integral of first kind, right? So here we have to solve this integral that is from 0 to 1, and the integrand is 1 minus square root of x raised to 8, right? So in this lecture we'll see a beautiful application of beta function to evaluate this type of integral, right? So let us start. So let us call this integral as I, right? So here what we will do, we'll make use of that method of substitution, right? So let us substitute square root of x as y, right? So y is now y square is equal to x, right? So let us differentiate both sides. So dy square is equal to dx, so we have 2y, dy is equal to dx, right? Now let us change the limits, right? So here x varies from 0 to 1. So when x is 0, then the value of y can be calculated from this relation. So y is equal to square root of 0, that is equal to 0. And when x is equal to 1, then the value of y is square root of 1, that is simply 1, right? So when x goes from 0 to 1, then y goes from 0 to 1. So now let us express this integral in terms of this new variable y, right? So now we can write I is equal to 0 to 1. We have 1 minus square root of x, which is replaced by y, and we have here the power 8, and dx is replaced by 2y dy, right? Okay, so now this 2 can be it can be taken out outside the integral. So we have 2, 0 to 1, 1 minus y raised to 8, and we are left with only y, right? So now we can express this integral as 0 to 1, and here we have y raised to 1. So y raised to 1 can be written as 2 minus 1, right? And 1 minus y raised to 8 can be written as 9 minus 1, right? So we have written this integral in this form in order to convert it into a beta function. Now see, the beta function, that is beta mn, is defined by this integral, that is 0 to 1, and we have say x raised to m minus 1 and 1 minus x raised to n minus 1 dx, right? Where m and n are greater than 0, right? So this integral is known as beta function, or the Eulerian integral of first kind. And here we see that this integral is similar to this one, right? Except the variable. So here we have y and here we have x. And see, if we compare this integral with this one, then see the value of m is 2, right? So this is m, and here we have 1 minus x, here we have 1 minus y, and the value of n is 9, right? So we have now this integral, that is 0 to 1, y raised to 2 minus 1, 1 minus y raised to 9 minus 1 dy is equal to beta of mn. So here we have beta, m is 2 and n is 9, right? So now this integral I can be written as 2 times, here we have 2 a factor, and then we have beta of 2 comma 9, right? So now we know that an important relation between the beta function and the gamma function, beta mn, is given by gamma of m, then gamma of n, and divided by gamma of m plus n, right? Where m and n are greater than 0, right? So here we have m is equal to 2 and n is equal to 9. So using this relation, we can write beta 2 comma 9 as gamma of 2, gamma of 9, and then we have gamma of 2 plus 9, right? So now we can write this integral I as 2 times gamma of 2, and we know that gamma of n is defined as, that is gamma of n plus 1 is defined as n factorial, right? Where n belongs to the set of natural numbers, right? So here, so when n belongs to the set of natural numbers, then gamma of n plus 1 is equal to n factorial. So here we have gamma of 2, right? So gamma of 2 can be written as 1 factorial, and then gamma of 9 can be written as 8 factorial, and in the denominator we have gamma of 11, and gamma 11 can be written as, here 1 factorial is 1, 8 factorial, and then gamma of 11 is equal to 10 factorial due to this relation, right? So now we can write 2 times 1 times 8 factorial. 10 factorial can be written as 10 times 9 times 8 factorial. 8 factorial and 8 factorial get cancelled. Here we have 2 5s are 10. So we have 1 over 5 times 9, that is equal to 1 over 45, right? So the value of this integral is equal to 1 over 45, right?